Okay, everybody, the Executive Director of Archbold Biological Station, Dr. Hilary Swain.
So I've been tasked today with giving you a very broad introduction, not so much just the natural history of the ridge, but more sort of why is the ridge here, how does it work as an ecosystem, what are some of the water patterns on the ridge, how does fire, sand and water interact on the Lake Wales Ridge. So this is, I'm going to do the tough parts, you know. I think Bill has some handouts which he's going to right in front of you, which he's going to hand out. Thank you very much. And think of this really as Ridge 101. You're in a college class and you're going to get some ridge basics. Can I ask before the beginning, has anyone seen me give this before? Okay, I apologize, you're getting the same talk. Let's start off thinking a little bit about where the ridge is and getting our geography sorted out. Bill gave you a great introduction there because he showed you in the state of Florida that the Lake Wales Ridge, in fact, it runs 116 miles from the south end, which is just going nearly into Glades County, all the way up to north of Claremont. So 116 mile ridge. And it's at least 1 to 2 million years old. So sea level has come and gone over the millennia, over hundreds of thousands of years. The Lake Wales Ridge has stood above all of this. So think of it as an ancient sand ridge that has stood the test of time, and a little bit like other isolated sand ridges as sea level came and went and came and went. The Lake Wales Ridge almost acted like a series of ancient islands or islands of sand. And just like those other ancient islands, the Galapagos, or the more recent ones, Hawaiian Islands, of course that's resulted in some very interesting biology, some very interesting geography because of this history of isolation and the other history of sort of really interesting adaptations to sand and to fire and to water. So let's think a little bit about where the Lake Wales Ridge came from. The Lake Wales Ridge is not a limestone ridge. It's not like Miami. It's not a calcareous limestone sand ridge. The Lake Wales Ridge came from outwash, or think of it as sand that came from the mountains of Georgia, the plains of Georgia, the sort of Piedmont of Georgia was washed down by sea level. You know, when you go to the beach now, you see sand drifting from north down to south. So the Lake Wales Ridge is built of erosion of mountain systems to the north of us, or hill systems to the north of us in Georgia. As a result, it's made of silica sand, quartz. It's not made of limestone sand. Silica sand is very acid, it's not calcareous, so everything we have here is acid loving. And it's very nutrient poor. A lot of that is because it's been here a very long time. You know, water has come, leached up and down in the sands of the Lake Wales Ridge. There's been a high loss of nutrients because of leaching. So species that live here have to rely on quartz, very poor nutrient sand, and highly acid conditions. And that changes the sort of things you see on the Lake Wales Ridge. That's why we have things like species that you would often see in a heath or in a moorland because they're acid loving. So all those so-called ericaceous or heather type or heath type species are found on the Lake Wales Ridge. So strong relationship with acid. This is why you find species like all the sundews that are desperately trying to get nutrients from trapping insects because they're in nutrient poor wetland soils on the Lake Wales Ridge. So it's really important to understand your geology, just like a master gardener. You have to understand the soil in your garden to understand what you can plant there. If you understand the geology and the history of the Lake Wales Ridge, you begin to understand the sorts of species that are associated here. And the other thing you understand is because of the age of the system, that these species have been very isolated for a very long time. So we have a whole series of sand ridges in Florida. This is the ancient one, the Lake Wales Ridge here. You'll notice that actually it's sort of a double ridge. There's a sort of shallow, some people call it inter-ridge valley, other people don't. But basically there's two higher sides that are highly sandy, and then a series of sinkhole or other depressional lakes through the middle of the ridge. So those are two characteristics. The other ridges all represent a series of sea level highs. So if you drive from the Lake Wales Ridge out sort of say across 60 to Vero Beach, you see the Lake Wales Ridge, and then you'll see other ridges on the side of the Kissimmee River. Then you get further out the Green Ridge, and then you see a ridge that's basically where 95 is. Of course people built down the ridges. All our road systems are built down ridges. You know, early road planners were not stupid. So 95 is down at the 10-mile ridge. A1A is down a ridge that's 100,000, 140,000 years old. Route 1 is down a ridge that's 140,000 years old. A1A runs down the modern Barrier Island, which is a 7,000-year-old ridge. And if you go on the left side, on the coast, although it's not quite so obvious, because this is a high-energy shoreline, the Atlantic is a high-energy shoreline. The beach ridges are very defined there. On the west side, you can see equivalent sea level highs and equivalent ridges, but they're not so sharply defined because this is the low energy shoreline. The Gulf is the low energy shoreline. But you can think of the sea level in Florida as a bit like a red carpet, rolling in and out and in and out, and then you have these sea level high stands left behind. And the oldest ones are in the middle of the state. And so really the Lake Wales Ridge is an old sand dune. It's an old beach sand dune with big wind-blown dunes. So these dunes that we see on the Lake Wales Ridge are a result of not so much wave action, but also wind action. And any of you have been to Cape Canaveral, you'll see when you go out on Cape Canaveral, you'll often feel like you're going over a series of little ridges as you go from when you arrive on the Barrier Island all the way out to the beach. Those are lots of little sea level highs that have happened. That's an accreting shoreline, a shoreline that's building out over time. So Cape Canaveral, the oldest ridges on Cape Canaveral are on this side, and they've been building out in a series of ridges that sort of go in that direction. So these are some of there are lots of debates about the names of the ridges, but basically these are the 8 major ridge systems in central Florida. And because of the age of the Lake Wales Ridge, many of the rarest species and many of the species found nowhere else are found on the Lake Wales Ridge. That's the sort of ancient one. The modern ridges, like the Barrier Island Ridge, the Atlantic Coastal Ridge, have a lot of the same species, but not the same density of extremely rare species.